Hi, in this video I'm going to be talking about how to use tables of data to map out regression lines on the TI-84 calculator, TI-83, same thing. And we're going to use that in order to get an equation out of the data. We're going to actually fit an equation, so we'll come up with something that looks like y equals in this case. Okay. The table below shows the typical speed, y, in feet per second, of a space shuttle the x seconds after it's launched. And so x, as we look at this, is representing time in seconds. Should have resized the table a little bit, make it fit a little bit better. Y is going to be the speed, and that is feet per second. Okay, so let's spread this out a little bit, make it look nicer. And the idea is this: given the values that are on the table, can we, number one, can we find a polynomial model for the data? That means, can you come up with an equation that fits this? And then two, can you use it to make a prediction? Predict with the time when the shuttle speed reaches 4,400 feet per second. That is to say, if I was going to go ahead and add another row below, and I wanted to know, based on this model, when would I hit 4,400 feet per second? That's the question. Okay, so we have to do two things. One, come up with the model. We'll do that over here. Two, figure out how many seconds after the launch this occurs. So what I'm going to do is I'm going to go through and I'm going to, first of all, enter information into my TI-84 calculator by hitting stat. Okay, and when I go into stat, it gives me some options here. I can either edit my table. Second option, if I scroll to the right, I can do calculations with my table. Or the third thing, I can do some tests with the table, and you'll use that in maybe like a statistics class, but we won't use it here. We want to edit our table, okay, because we don't have any information in there. So I'm going to hit enter, and I'm just going to start typing in values. So I'm going to hit 10, enter, 20, 30, 40, 50, 60, 70, and 80. I'm going to go scroll over to the next column, and I'm going to enter in all my y values. And it's important that you do x's first and y's second. So I have 202 point, oh, that didn't work correctly, did it? 202, I guess I have to type the dot, 4. And I have 463.3. And I have 748.2. You're starting to get the idea already that the longest part of this problem is going to be entering in data. 1186.3, 1421.3, 1795.4, and 2283.5. Notice I'm not putting in the 4400 because that's something we're going to use to make a prediction later on. That's not an actual data point that we have. So here we go. We're almost done. What we're going to do now is we're done entering information in the table, so I'm going to hit second, and then I'm going to hit quit. I'm going to get out of this completely. So I'm not editing my table anymore, but I am going to go back into the stat menu. This time I'm not going to edit my table. I'm going to go over one menu to calculation, and I'm going to find a model that fits. They give me a bunch of different options here. Quad means, do I think it's an x to the fourth equation? Cubic means, do I think, quad means it's x squared. Cubic would mean x cubed. Quartic would be x to the fourth. Or I can do linear regression, which is y equals mx plus b. Okay, so what I need to do in order to kind of figure this out is, am I looking for a parabola? Do my dots form an S curve? That would be cubic. Or is it quartic, where maybe it's parabola, but it goes up faster than parabola? And that's kind of tough to determine sometimes. So the easiest way to do this is, you know what, let's just go graph. Let's go look at y equals. Now I'm going to scroll up to plot 1, and I'm going to hit enter. And now that it's blackened in, that means I'm going to graph it. Okay, so I hit graph. Oh, nothing shows up. Well, here's the problem here. You might look at my y values and say, wait a second, those things go all the way up to like 2200. And this only goes up to 10. That's a height of 10. So I need to go adjust my window a little bit. The easiest way, we can use window and type in values, but if with statistics, what's really nice is if I have an option where I can go, and option 9 is zoom to fit statistics. So I'm going to hit enter here. Look at that. Okay, that to me looks kind of like the beginning of an S curve. I know it's a very slight S curve, but you can see it goes up and then it kind of dips off a little bit and then it goes up some more. So let's fit an x cubed, a cubic model, to this equation. I can tell from looking at that picture. Here we go. Stat menu. Calculate. Scroll down, and let's do a cubic regression line. And all I have to do is hit enter, and it tells me, aha, here's the model. Ready? A is the value in front of the x cubed, so it's 0.0065 x cubes. Well, I need to do something to keep that on top at the same time, don't I? Okay, let's minimize that a little bit. There we go. 0.0065 x cubes. And then the second thing we see is minus 0.7394 minus 0.7394 x squareds. The third number is 48.9562 plus 48.9562 x's minus, and then the constant here off at the end, d is negative 235.8857. Okay. And so I'll reduce the text a little bit since it's too big to fit in one line. Okay, that would be the equation based on the calculator. Okay, so last part of this, ready? When y is 4400, what is x? That's what we're trying to figure out, right? When the speed hits 4400, how long did it take? You could solve that by hand. That would be terrible. I wouldn't recommend doing that. I think the easier way is just do this. I'm going to graph the line. First of all, the question is, I guess, here's what I could do. Since I'm trying to show work for you guys on your notes. If I go to the next line, I type it in again. This time the question is, if I type in 4400 for y, what do I get for x, right? Does that make sense? And so the left side becomes y1. We've done this multiple times, haven't we? And the right side becomes y2, 0.0065 x cubed minus 0.7394 x squared plus 48.9562 x minus 235 point, whoops, that didn't work well, did it? Let's go back and minus 235.8857. Okay, now what you're going to see, now I left the dots up there, that's still darkened in. Notice the equal signs are darkened in, so I'm going to have two lines and one set of scatter plots that's going to get graphed in a second, okay? And if I typed in my line correctly, okay, we can see that there's the fit. Did I type that in correctly? I wonder now. I wonder if I missed something. 0.0065 x cubed minus I did mess up here. Let's try this again. That's 0.7394 x squared plus 48.9562 x minus 235.8. Now let's try to graph it. Whoa, look at the difference that made. I was only off by 1/10 on the x squared. Okay, so now the problem is that I don't see the line that says 4400, and that's because my window only goes up to maybe 2500. So now I do have to manually adjust my window. I want to get at least 4400, so maybe I'll put 4500 in there. So now my y value goes up high enough, and now I graph it, and I can see that there's the line. Now it looks like maybe I'm not going far enough in the x direction. So I'm going to go change my maximum my maximum x value. It needs to go past 87. Let's do like, let's just be ridiculous here, like 120 or something, okay? Aha, I can see that they're going to cross right up here at this point. So to find that intersection point then, I go second, calc, intersect, I hit enter. I'm just going to walk the cursor over till I'm pretty darn close to that spot, and when I'm close enough, I'm just going to hit enter, 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 enter. It happens, y is 4400 when x is 106.115. So the answer to my question is this. Find a polynomial model for the data. Boom, there it is, the first one. And then the second part of the question is predict when the speed reaches 4400 feet per second. It reaches 4400 feet per second, 106.115 seconds after launch. So we just did all that with the graphing calculator. If you know how to enter the table and how to scatter plot and fit data do second calc intersect. You know, it's really only like 35 different skills you just use in the graphing calculator, many of which we've practiced before, so hopefully that makes sense. Most of that should be a review. The new thing was how do I enter statistics in and then get that cubic regression line. So there we go. We'll have a chance to practice a lot of these in class, and like you probably just saw, a main majority of your time will just be entering data into the calculator.